Uh, Hello, can you hear me? Checking. Waiting. Can one of you text in the chat if you can hear me and you can see my video?
Yes, Samadip, your screen is visible and you're audible.
Okay. Okay, thank you. Right. Yeah, I've gotten the text. So, a second. Just give me a second. Let me set this up properly. Right. So, hello everyone. So I'll be sharing the notes hopefully with you after the class. But so I hope you are in the right tutorial. This is for Introduction to Queuing Theory. It's an NPTEL course, and so we will be covering weeks 0 to 1 in today's tutorial. So in week 0, we did an overview of probability. And in week 1, we got started with queuing theory, right? So, so I think that's a pretty good introduction for the course and what's what to expect. And yeah, so what I'll try to do is kind of touch on a few concepts, and then we can do some basic problem solving, and then we can proceed with any additional doubts that you may have. Let's wait till, okay, so I have 3 students here. Let's wait till 3 or 5, maybe before we start, just 1 or 2 minutes. Okay, let's start. So, so as you can see, I kind of drew a very random sketch here. So this is a rectangle, let's say representing a set, and I have kind of partitioned this set into, I chose the number 7 because I like it. So I've partitioned the set into 7 partitions, right? So from set notation, I can write A1 union A2 union A7. This is equal to the complete set, right? And so this is one, and also another property is that A1 intersection. So this we can also write it in a notation form as union of all sets from I equal to 1 to 7 AI is equal to the complete set, right? And another property that holds is for ij belonging to any values 1 to 7, we will have AI intersection AJ is equal to 5. So these are mutually exclusive events, right? So this property is exhaustive, and this is mutually exclusive, right? So what is the value of summation over all I equal to 1 to 7 probability that um uh, like probability that something in the set xi belongs to AI? Can somebody give me the answer? Yes, curious. Like, okay, I equal to 1 to 7. It should be clear. So this is
1.
yes, exactly, because this is a mutually exclusive and exhaustive collection. So whatever element you pick from the set xi has to lie in one of these, right? And these sets are not intersecting with each other. So this has to be 1. So this is kind of the first axiom, I think. I mean, I'm probably not right about the ordering, and then this is an application of the first axiom, and then another property I've already stated, but what will be the probability of AI intersection AJ, I not equal to J? Can I get the answer for this? Can I get the answer for this?
0.
Yes, because AI intersection AJ is fine. There is no common element. So we'll have the probability to be 0. Very good. And so the third property is also that since these are mutually exhaustive, what will be P of AI union AJ? Whatever be the value of I and J. Oh, sorry. Actually, we should clarify. I not equal to J. I not equal to J. What will be the probability? This should be P of AI plus P of AJ, right? Because like we can take, let's say, A1 and A2, probability that any element lies in the union of, because these two sets have no intersection, we can only have two situations, right? We can only have the set belonging to A1 or to A2. Similarly for all of these sets, because they don't intersect with each other. And so from these, you can actually derive a very fundamental theorem, which is, and we all know another axiom, right? That probabilities are always positive. So we can also derive that probability of any set here, P of AI, has to lie between 0 and 1, right? So we know that probability by definition is always positive, but the one is actually the probability of the complete set, right? So here, which is same as this quantity. So P of AI for any I has to be less or equal to the probability of the complete summation over all i's, because each quantity is positive, and then this summation is equal to 1. So this is kind of the basic axioms of probability that will help us solve many kinds of problems, right? So now let us do another kind of qualitative question. So I'll give 3 statements, and you have to tell me which of these will always hold for for any situation, right? So let's see. These are the 3 statements. The question is, which of the, is my handwriting visible? Yes.
Yeah, it's visible.
Okay. Which of the following is always true? Something like that. So the first one is that, so I'll just write down the 3 statements. And let's make this is or are. Multiple of them may be correct. True. The first one is for, so X, Y are random variable. I'm writing in short. So in that case, expectation of X plus Y equal to expectation of X plus expectation of Y. Right? So this is one. Second is, so let's say X is a random variable where, so the PDF of X, which is this is a function which is from the domain, like it has an infinite domain, and it also maps to positive values. Let's say. Something, yeah. That's pretty much all we know. And it also can give an infinite range. But actually, let's make it simple. Let's make it like a finite range, something like PDF will only vary from 0 to, let's say, some value 100. That's the maximum this will go to. So actually, we can make it a general range R. So the key idea is the PDF. So this is some random variable with a PDF fx of x that is defined over the positive. This is defined over the positive real axis, right? Fx of x. That is defined some function like this, something like that. It's defined for all of the points taken. So then given this, can we say that expectation of x is infinite? Let's put a question mark. Doesn't matter. So yeah, so the x is defined over infinite set. Can we say that expectation of x is infinite? And third is, let's say, again, so I have two sets. Again, so I have A1 and A2, both are a subset of a bigger set, let's say B, right? That's all I know. Can I say that probability of A1 intersection A2 equal to probability A1 times probability of A2? So B is like a big set of events and A1 and A2 are the subsets. So can I always say this? Can somebody answer? I can discuss.
Yeah, A is correct.
Yeah, A
And
is
then
correct.
I mean, for me, I think A is correct. And then like C, if A1 and A2 are independent, I think C is also correct.
Yes, you are right. A1 and A2 have to be independent, but that might not always be the case. So in general, so if you're asked this question in general for any A1 and A2, this might not hold, right? So in that way, it is incorrect. Like, I'm just talking, let's say you get an MCQ question like this, you should probably mark it wrong because that information is not provided, that A1 and A2
Okay.
are who was this? Sorry. Yeah, so that information is not provided. So in general, you can answer this as incorrect because, yeah, it won't always be true. And then the second one, any thoughts?
Second, sorry, I don't know. Maybe other participants.
Yeah. Okay, so the second one is actually wrong because you have many such examples, right? You have the Gaussian PDF. Let's say Gaussian with, actually, let's take the exponential, right? it is somewhat like this. Let's say f of x equal to something like e to the power minus x. So this is defined over the entire range, right? From 0 to infinity. But the expectation of x, if you compute expectation of x, let's quickly do it. It's x e to the power minus x dx from 0 to infinity. It will come out to be some finite value always. It will be probably something like x, what's the integration? Minus 1 plus x into the power minus x from 0 to infinity. Yeah, so you will most likely, I think the value comes out to be 1. You can check the calculation, but it comes out to be a finite value. So it is not necessary that expectation of x is infinite if the support set is infinite. Right? So yeah, that was kind of a quick refresher. And yeah, what else? Now, similarly, any other any doubts on these kind of questions? Yes, somebody's on late. Okay, so let's solve another problem. So you are playing a game of dice throwing, right? You're playing some game where you need to throw dice, and as a dice, the number n can take values 1, 2, 6, right? These are the 6 numbers that you can generate in one throw. And so you are given that probability that and this is not a fair dice, there is some kind of unfair loading, etc. You are given then the probability that you get the number I, where so x is the random variable denoting the number on the face of the. So this is like, let's say, your xi here on the face of the die. So let's say this probability, you're given some kind of formula that it is like some constant c divided by I, I plus 2, let's say. C is some constant. C not equal to 0, of course. Actually, C greater than 0. So, and I equal to 1 to 6. Can anyone tell me how do we calculate C? So I need to find the value of C. Can somebody suggest? Okay. Take maybe 1 minute. Let's see.
Maybe like if you are rolling the dice once, it is the probability is 1 by 6 actually. So
no, so that is for a fair die, right? That is, so I'm giving you an unfair die. A fair die is where all of the faces are perfectly symmetrical, and so that is why it will be equal. Now let's say I'm giving you a die which is not symmetrical, which has issues, like which is kind of broken in one side, etc., etc. Does that make sense? So I'm giving you a faulty die where somebody has found out that it goes like the probability that x is equal to I, that you get the face I goes as 1 by I plus 2 times some proportionality constant. And your job is to find the proportionality constant. Does that make sense?
Okay.
Yeah, it's not a fair die. It's not like perfect die. It's a faulty die. So you have to work with that. Okay. Okay. Let me give you the kind of answer. Or let me help you at least. Can you tell me what is this value? Probability, sum of probability x equal to I equal to 1 to 6. I just covered it a few steps back. Can you
It's
tell
one
me what
actually.
this is? 1,
Yeah.
right? Now can you solve? Can you suggest me a way to approach this?
So we have to sum all the C by I plus 2
Exactly.
for
Yes. So
all
you
I
take,
equal to.
yeah, C is common, so you will just sum I equal to 1 to 6, 1 by I plus 2 equal to 1. And so I'm leaving the rest to you. I mean, I just kind of cooked up the numbers, so I really don't have the solution for this, but this is pretty easy, right? You can find this sum and take the and solve this equation. So then you will get the value of C equal to something. I can fill in the details, I guess. So this is a simple application of the property that we discussed earlier. So yeah, so this is one. Now, okay, let's deal with. So this was this kind of distribution over here. This kind of random variable is called. So you have two kinds of random variables, right? So x can be a discrete random variable, or it can be a continuous random variable, right? So I've kind of, so this random variable that we just discussed here, where x denotes the number on the face of a die, what kind of random variable is this?
This is a discrete random variable.
Yes, this is discrete. So like one example is face of a die. Continuous random variables, on the other hand, will be, in real life, it will be depicting numbers that can take, a real valued range. Let's say I come from an electrical engineering background, so let's say I'm measuring the voltage of some circuit element, and then I want to predict that the value of voltage of that circuit element, right? I want to predict, and like I want to create a probability distribution. Now this voltage V can take the value from minus infinity to infinity almost, right? Because voltages can be negative, positive, it can take any value, but it has to be a real numbered value. We cannot have, typically in real circuits, we won't be dealing with imaginary voltages. So these are the two kind of random variables. And so let's now deal with a continuous random variable, right? So one favorite random variable is Gaussian, right? And also exponential and all of that, right? So one important characteristic of any random variable is something known as moment generating function, right? Or let's not go there. Let's first start with simple things like a PDF, right? So I have, let's say, a Gaussian random variable, normal 0, 1. I hope people are familiar with the notation. This denotes the mean of the normal distribution, and this denotes the standard deviation of the normal distribution. So So what is the CDF of this function? So CDF is defined as probability that of this variable, the probability that x is less or equal to x. So, and then so the PDF of a Gaussian random variable is 1 by root over 2 pi sigma square e to the power minus x minus mu whole square by 2 sigma square, right? And so for normal 0, 1, it will become 1 by root 2 pi e to the power minus x. Mu is 0, so it will be x by 2. X square by 2, sorry. X square by 2. And so the probability that x is less or equal to a certain value x will essentially be this integration of this distribution function from minus infinity till x. Now this cannot be exactly solved, it is numerically solved and it depends on the value of x. Here of course minus infinity less or equal to x less or equal to infinity. But can we tell the value of these three quantities? Firstly, let us try fx of minus infinity. Can we tell what this value will be? Just from this expression here. This will be 0, right? Because I'll be integrating from minus infinity to minus infinity and that won't amount to anything. So that is from the formula. But logically speaking, I cannot have anything less than equal to minus infinity. Something like that just doesn't exist. So this is one axiom, you might say, of the distribution function. Then the second value is fx of plus infinity. This, can somebody give me the answer?
It's minus infinity to plus infinity.
Yeah, so what will be the answer? The answer will be 1, right? Because logically speaking, any value has to be less than infinity, right? So then this is another axiom. So one way to check, so essentially what this gives us is this result that this function, which is known as the PDF of the Gaussian, this integration. So we know the solution to this integration essentially. This is otherwise you cannot solve it using, the regular integration techniques that we know. But we know that the solution to this integration is 1. Because this is a Gaussian PDF and it is continuous over its whole range, and you can from the property of distribution function, you can get the value of this integration. And then the third property, which is special for Gaussian, is what is the value of this quantity? For Gaussian and in general other symmetric distribution functions. For this, let us very quickly draw the PDF here of Gaussian. Just a second. I need to charge my laptop. So this is the PDF of the Gaussian distribution. This is 1 over root 2 pi. And then this is how it goes. This is 0. This is plus infinity. This is minus infinity. This answer is half. Because very simply, this is a symmetric, like even if you forget other properties. This PDF is an even function, right? Odd even functions, it has the same value for like both. You can see it, that it is symmetric around x equal to 0. So by that property itself, this, so fx of 0 will be, this value will be minus infinity to 0, 1 over root over 2 pi e to the power minus half x square dx, right? And this will be exactly the same as if you integrate this same function. Now this is minus half x squared, and so this will be exactly the same as if you integrate the function from 0 to infinity, right? Because just look at these areas, this area, and let's say I circle this with bubbles, they have exactly the same area. So since these two quantities are equal, and we know that minus infinity to infinity is nothing but union of minus infinity to 0 and 0 to infinity, right? You can kind of take the singular points, doesn't matter. So then these two probabilities added up will give you 1, because the integration from minus infinity to infinity is known to be 1. So yeah, so then individually each of these quantities is half, and because these are equal and they add up to 1, so each of these quantities is half. So you get the answer from here that fx of 0, which is integration of minus infinity to 0 of the Gaussian distribution function 2 pi e to the power minus half x square dx equal to half. This is purely because of the symmetry property. And in general, for any Gaussian, let's say you have some Gaussian function with a mean mu and standard variance sigma, your value fx of mu will be equal to half, because it's just symmetric around the mean. Is this clear?
Yeah, for me it's clear.
Okay. So